Okay, this is example 1 here, solving absolute value equations. As we know, absolute value is the distance a number is from 0. So therefore, what the number inside the absolute value can be 7 or -7 because they both equal. The absolute value of 7 is 7 and the absolute value of -7 is also 7. So basically we're saying this absolute value, 3x plus 2, can equal 7, or it could equal -7. So we have to solve x for each of these equations because there's two possible values for x. The value of x that makes this 7 and the value of x that makes that -7. So you know how to solve equations here. So we're going to have 3x equals 5 and then 3x equals -9. Solve x is 5/3. I know if I did 5 divided by 3 I would get 1 2/3 or 1.6 repeating. Like I told you before, repeating decimals, I don't like us to round them, so keep it as a fraction. And then this would be x equals -3. And then always be sure to check, because now we're getting into aspects where we can have extraneous solutions, which you should already have the definition written down for that. So plug it in. 3 times -3 is -9, -9 plus 2 is -7, absolute value -7. This checks out, we're good. X equals 5/3. Well, 3 times 5/3 is 5, 5 plus 2 is 7, absolute value of 7 is 7, so that checks. We're good there as well. Let's move on. Example 2, okay, we again have an absolute value, but this one's a little bit harder because we can't just say, all right, 2 times absolute value of 3x minus 1 plus 5 equals 33, and then change it to -33. That whole change process only worked here because the absolute value was already by itself. So the first thing we have to do is actually get the absolute value by itself. See what the absolute value equals. So in this case, we're going to subtract 5 from both sides. So we'll have 2, absolute value of 3x minus 1 equals 28. Okay, now this still isn't by itself. Divide by 2. Okay, so we'll have 3x minus 1, the absolute value of 3x minus 1 equals 14. Okay, now the absolute value is by itself, so this is where we can say, all right, this absolute value can equal 14, so 3x minus 1 can equal 14, or 3x minus 1 can equal -14. And then once again, we solve. Add 1, so we'll have 3x equals 15, divide x equals 5. And then add 1, 3x equals -13, divide by 3. Again, we get a repeating decimal, so I'm going to leave it as -13/3. By all means, check. And whenever you check, always plug it back into the original, because you may have made an error here somewhere. So plug it into the original, make sure we're good. So plug 5 in, 3 times 5 is 15, 15 minus 1 is 14, 2 times 14, absolute value of 14 is 14, 2 times 14 is 28, 28 plus 5 is 33. This checks, we're good, let's look here. -13 times 3, well 3 times -13/3 is -13, -13 minus 1 is -14, absolute value of -14 is +14, 2 times +14 is 28, 28 plus 5 is 33. Perfect, that checks out as well. Let's look at example 3 then. We have absolute value of 2x plus 3 equals 3x plus 2. Same thing. This absolute value can equal this positive number, 2x plus 3 equals 3x plus 2, or it can equal its opposite, so -3x minus 2. Okay, so let's solve that. I'm going to subtract 2 and subtract 2x, so I'll get 1 equals x, or 1x, and then here I am going to add 3x and subtract 3, and I'll get 5x equals -5, so x equals -1. And let's plug this in. When x is 1, 2 times 1 is 2, 2 plus 3 is 5, absolute value of 5 is 5. Okay, equals 3 times 1 is 3, 3 plus 2 is 5, 5 equals 5, that checks out, we're good. Here, 2 times negative 1 is negative 2 plus 3 is negative 1. Absolute value of negative 1 is positive 1. 3 times negative 1 is negative 3 plus 2 is negative 1. 1 and negative 1 do not equal the same thing, so this is what is known as an extraneous solution. You did all of your work correctly, however, once plugged back in, it does not equal, it doesn't work in the original equation. So this is an extraneous solution and does not work. Our only solution is x equals 1. Okay, example 4. We had to solve this inequality and graph. Same concept. We are going to say, all right, 2x minus 3, the absolute value of 2x minus 3 can be greater than 7. Or, remember, when we divide by negatives, it flips. So, or 2x minus 3 can be less than negative 7. So that inequality sign needs to flip. I'm sorry, from your notes, you should know if this is an or an and. Off the top of my head, I don't remember, so I'm going to solve the equation, and then that will tell me what it is. So I'm going to add 3 to both sides here, and I get 2x is greater than 10, so x is greater than 5. Add 3 is less than negative 4, x is less than negative 2. So this is an or statement. So all my greater thans must be ors. Because when I graph it, I have 5, 4, 3, 2, 1, 0, negative 1, negative 2. Okay, open circles, remember, so I have an open circle at 5, and I'm going to shade greater than that. And then I'm going to have an open circle here at negative 2 and shade less than that. So either one of those. So I could pick 6 or negative 3, and it should work in my original. So I can check. Let's do 6. 2 times 6 is 12. 12 minus 3 is 9. Absolute value 9 is 9. 9 is greater than 7. Yep, that definitely works out. Let's check here. Negative 3. 2 times negative 3 is negative 6. Negative 6 minus 3 is negative 9. Absolute value negative 9 is positive 9. So that checks as well. So we're good. Example 5. So, same thing, let's solve and graph. Again, you need to get the inequality by itself, or sorry, the absolute value by itself first. Right here we have minus 7, so let's get rid of it and add 7. So it's going to turn it into the absolute value of 5z plus 3 is less than 41. Now it's by itself, so we can rewrite it. 5z plus 3 is less than 41, and 5z plus 3 is greater than negative 41. Let's assume I don't know if this is an and or an or statement, so let's go through and solve it. Minus 3, so we'll have 5z equals 30, sorry, is less than 38, and we'll have 5z is greater than negative 44. Divide by 5. So I'm going to have z is less than 7 point. 35 divided by 5 is 7.6. And then this will be z is greater than negative 8.8. Okay, so it has to be greater than negative 8.8. So I'm going to say this is negative 9, negative 8, negative, I'm going to go by, sorry, I'm going to go by 2's here. Negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8. Open circle at negative 8.8, which would be about here. And it has to be greater than that, so this must be an and statement. And less than 7.6, again, open circle, and it has to be less than that. So we shaded in between the two. Okay, make sure if you have any questions, you bring them tomorrow. I know it was pretty heavy, but we're already fairly decent at solving equations, so I thought, let's throw this all together and do it in one. Sorry for the long video, but as you can see, it was completely necessary. Have a good night, and bring in anything tomorrow.